Hello friends, today I'll be discussing with you question number 15 of GATE Physics 2017. The question goes like this: the contour integral dz by 1 plus z square evaluated along a contour going from minus infinity to plus infinity along the real axis and closed in the lower half plane by a half circle is equal to dash. So let us have a look at the solution to this question. Now for this problem, we are asked to find out integration of dz by 1 plus z square for this given curve C. And we have been given that it's a region in the lower half plane. So it's a semicircle. And it is mentioned that the curve is traced from minus infinity to plus infinity in the real axis. That means it will be going from minus infinity to plus infinity. So this is my real axis, this x-axis. So minus infinity to plus infinity. So this direction has to be like this. And therefore, if I draw the trace fully, then it will be like this. And this is a clockwise motion. So our problem is associated with a clockwise trace. And for this problem, to evaluate the integral, we have to use the residue theorem. Now the residue theorem is given like this: integration of fz dz over the given curve C is equal to 2 pi I into a minus 1. And this is for a path which is traced anticlockwise. And if the path is traced clockwise, then we'll have a minus sign over here in the right hand side. And so for this given problem, our concerned equation will be this one. Now this a minus is the residue, which is given as limit of z tending to a 1 by k minus 1 factorial d to the power of k minus 1 by dz to the power of k minus 1 into z minus a to the power k into fz. So first of all, we have to find out the poles for this given fz. So fz is given as 1 by 1 plus z square. And to find out the poles, we know that this must go to infinity. And for that to happen, my 1 plus z square should be equal to 0. So that would imply that my z is equal to plus minus root under of minus 1. And root under of minus 1, we know it is I. And therefore my z will be equal to plus I and minus I. So these are the two poles that we obtain for this fz. Now if we look at these two poles, then we can easily see that plus I will lie somewhere over here in the positive part, and this negative I will lie in this negative half. And we can easily see that this plus I is out of the given region that we are concerned, and only minus I will lie in the given region. And therefore this plus I will not contribute to the required integral. So only z that will contribute to the required integral is this minus I. So we have to find out the residue for this z equals to minus I. And since this z equals to minus I is a simple pole, therefore the k value will be equal to 1. And therefore the residue a minus 1 will be given as limit of z tending to a, which is minus I, into 1 by k minus 1. So k is 1. So 1 minus 1 factorial d to the power of k minus 1. So 1 minus 1 divided by dz to the power of k minus 1. So 1 minus 1 into z minus a, which is z minus I into fz, which is 1 by 1 plus z square, and that can be written as z minus I into z plus I. And this k is 1 because the power of z over here is 1. That is why this z equals to plus I and minus I are the simple poles. So we have a minus 1 given by this equation. So that reduces to 1 by 0 factorial d to the power of 0 dz to the power of 0, and over here we'll have z plus I divided by z minus I, z plus I. So z plus I cancels. So we are left with z minus I. And this 0 factorial, we know it is 1, and this also becomes 1. So 1 into 1, and over here we have 1 by z minus I. So limit of z tending to minus I, 1 by z minus I. So z becomes minus I, therefore my expression becomes 1 by minus I, and that becomes minus 1 by 2I. And minus 1 is, we know, it is I square, therefore my a minus 1 becomes I by 2. Now if we substitute the value of a minus 1 in the required integral, then we find my integration of dz 1 plus z square becomes minus 2 pi I into I by 2. So 2 cancels, so we are left with minus pi I square, and I square we know that is equal to minus 1. So minus into minus, that gives me plus, and that becomes plus pi, and pi we know it is 3.14. Therefore the given integral reduces to pi, which is equal to 3.14, and therefore the integration of dz by 1 plus z square is equal to 3.14. So the correct answer for this question is 3.14. So that's it. Thank you.